Good afternoon and welcome to Zahn Academy's Quick Bite. Our program today is VHF, the definitive difference in milling machines. Our speaker today is Nate Sigman, who is a technical trainer for Zahn Dental. We will be taking questions at the end of this webinar, so if you have any questions, please type them in for us. And at the very end, I'll come back on and we will answer the questions one by one. Thank you so much. Enjoy the webinar, and here's Nate.
All right, thank you, Fran. Hi, everyone. Thank you for attending the webinar today. My name is Nate Sigman. I'll be talking about VHF and their definitive differences in milling machines. So just a little bit of background on myself. I'm a technical trainer with Zahn Dental. I grew up working in my dad's dental office in Illinois as a chairside dental assistant. It's kind of where I got my interest in dentistry to begin with. I then attended the University of Colorado Boulder, where I studied biology. And after graduating, I kind of realized I really had a passion for technology. And I started working with Zahn Dental about 3 years ago. And since then, I've been doing installations, trainings, and technical support on various CAD/CAM systems that we offer. I really have a passion for helping implement modern technology into dental laboratories and to help them succeed. Just kind of a quick overview of what we're going to talk about today. I'll give you a quick introduction into VHF and who they are as a company. We'll talk about how they do a great job of balancing both form and function within their milling equipment. We'll discuss various material options that VHF has available for use with their machines. We'll talk about tools and tool management. We'll also talk about their softwares, Dental CAM and Dental CNC, and we'll dive into some of the milling strategies and customization options that users have available to them. And we'll talk about two of kind of my favorite features within those softwares, which is the residual material display feature and also the cavity and screw channel detection. At the end, we'll take some time for Q&A. I'll be able to answer any questions that you guys might have. All right, so who is VHF? VHF is a German-based company. They've been around for over 30 years, and they develop CNC machines, tools, and CAM software. So they have a headquarters in Germany where they do all of their manufacturing of their products. You can see in that middle picture there. But they also have an office in Hauppauge, New York, where they offer support, training, and repair services to US-based dental partners. So that really gives us an advantage when we're dealing with support issues for customers in the United States. Repairs, we have really quick and easy access to VHF representatives to cut down on downtime and to give us really easy access to some of these resources. As you can see on the bottom left, VHF, their motto is creating perfection. They're always looking for ways to improve on their products and really create the perfect machines. So one thing that VHF, I think, does a really great job of is balancing both form and function. So everything is 100% German engineered from VHF, and they have full control over their manufacturing process. So having that single manufacturing center in Germany out of their headquarters that we talked about allows them to produce all of their parts, and they have complete control over that manufacturing process as well as quality control. They also have, their mills are really robust. They have cast aluminum bodies that cover a really small footprint. There's a lot of weight in a very small footprint, and that allows for the reduction of vibrations during machining. So to kind of get the most accurate milling results, that's something they take great pride in is a solid cast body aluminum frame. And they also, to complement that, have very robust spindles with hybrid ceramic ball bearings. So having a really robust spindle, a strong and powerful spindle in all of these machines just opens up the door for a wide range of materials that can be used in these machines, and which we'll get into in a little bit. There's very, very tough materials like cobalt chrome and titanium, and having a spindle that you can rely on is very, very important for these dental milling machines. They also have a lot of these machines feature built-in webcams used for advanced technical support. So today's technician does not have time to sit there and watch, a job be milled. And so when a burr breaks, or if there's any sort of chipping issue or any issues with the milling machine, it becomes a little bit of a guessing game with technical support. And having that built-in webcam to store videos on customer computers allows our technical support team, as well as VHF's technical support team, to quickly look back and actually see what happened. So that's going to reduce downtime, and it's just going to make the whole technical support experience that much better. As you can see here, one of the things that VHF really prides themselves on are modern designs, really beautiful looking equipment that fits well in most laboratory settings. So they also have ionizers built into them. That's kind of something that's become standard in VHF machines. Also kind of reduces downtime and increases production by allowing users to really quickly remove waste material from their machine after it accumulates after a milling job. So it reduces static charge, allows that waste to be really easily wiped out from the inside of the machine. Another great feature with VHF machines that I like to touch on is that all of the software and licensing for these machines is stored on the controller of the unit itself. So as long as that milling machine is connected to a computer with both Dental CAM and Dental CNC programs, those programs will be able to pick up on that licensing, and they'll be able to use your software without any issues. So no yearly subscriptions. As long as you have the milling machine, you're good to use that software for as long as you like. So talking about material options, VHF believes in this open system that gives labs an unlimited selection of material types, sizes, and brands to choose from. So having that really durable spindle opens the door for a lot of different materials that customers can use with their machines. This gives customers complete control over their restoration aesthetics. With all the materials that are on the market today, I think it's really important for a user to be able to select whatever material it is that they want to mill. And they accomplish this by also giving users the ability to mill 98mm discs, which is pretty standard for material today. But they also have adapters for both blocks and abutment blanks. So for milling Emax blocks, also for milling titanium abutments, they have lots of different adapters that allow VHF to cover a wide range of material types and sizes. Along with that, they also have the ability to customize material options within Dental CAM, which is going to be your nesting software from VHF. So it allows users to really customize the list of materials that they see when they're working in Dental CAM. And it also allows users to make adjustments to certain material types as far as milling strategies, optional tools, and stuff like that. So speaking on milling tools, so when you have the ability to mill lots of different material types, it's very important that you have milling tools that are also specialized to work with those materials. So all of these tools are manufactured by VHF, and they've been optimized to work really perfectly with VHF machines and milling strategies. So a really big advantage to VHF is that by manufacturing not only the machines, but the spindles and the tools, they've been able to do a lot of research and development in terms of optimizing the quality and the performance of their milling tools. So they offer a wide range of tools for zirconia, PMMA, non-precious metals, and also glass ceramics. So with all those tools and different options, one of the problems becomes just keeping everything organized. And VHF has come up with a very, very good system by establishing match codes and both colored rings to allow for easy identification of tool type. So as you see here on the left is kind of an example. We have Z100 R2D40, and just that small bit of text that gives us a lot of information about what that tool is, what material it's used for, and also the size of the tool. So you can see Z for zirconia, we got 100, which represents that it's a 1mm tool. If it said 060, that would be a 0.6mm tool or a little bit of a smaller tool. And you can see also information about the number of cutting teeth, whether or not it's diamond coated, and also the length of the tool. So they pack a lot of information into a short code there, and that code is actually laser etched onto the tool itself. So it's very difficult to get these tools mixed up. And that colored ring that you see there in the picture gives us a really quick indication on what type of material this tool is used for. So right here, blue would be represent like a zirconia tool. So it's really difficult, even with the large amount of tools that customers have available to them. It's very difficult for them to get mixed up. So again, when you have all these tools, one of the problems becomes keeping everything well organized within the software. And so Dental CNC, which is VHF CNC software that allows users to control their machine and also manage tools, it gives users full control over their tool management by allowing them to register and place tools in any slot of their machine. So lots of milling companies, you're a little bit limited in the software in terms of where you can place your tools. So the strategies will tell customers that they have to put their tools in certain slots. What VHF has done is they've given users to register their tools and then place those tools in any slots of their milling machine. And as long as the software has been told where those tools have been placed, the mill will then know to grab those tools when they're needed. So aside from that, they also have this administrative tool board, or an ATB, that allows technicians to store and track tool life for up to 30 tools outside of the milling machine. And you can see a picture of that in the bottom left-hand corner. So what this is really useful for is storing tools, because you have a little bit of a limited capacity within the mill as far as tools that you can use. And so whenever you're not using a tool, you can store them in this ATB, and it will actually remember, as long as you have that registered in the corresponding slot within Dental CNC, it will remember that tool life of that tool, even if it's a used tool, and then you could grab it and place it in the mill and move it over, and it will remember that tool life, and it will allow you to keep using it and basically track the tool life of many more tools than you can actually fit inside of the machine. So another really great solution for managing a lot of tools for a lot of different material types. All right, so to touch on Dental CAM and Dental CNC a little bit more, these are the software applications that VHF has developed for both nesting and for managing certain aspects of the milling machine. So they provide a fast and effective solution for nesting, calculating, and processing jobs. And again, by having both of these programs made by VHF, they've done a great job of creating this kind of seamless integration between both applications. So after you nest and you calculate a job, that job gets immediately sent over to CNC, where you could continue to you could basically output that job to the mill right away without any downtime. They also, sticking with this open system theme, they give users the ability to import STL files from any CAD system. So regardless of the CAD program you're using for design, as long as you have the ability to output those designs as STL files, you'll be able to import those into Dental CAM, where you'll be able to do your nesting, add your supports, and calculate that and send it to the mill. So it gives users a lot more flexibility over what applications they decide to use for design. In addition to all of that, they give users customization options for milling strategies, materials, which we'll get into and here in just a second. But like other applications that might require some kind of an admin password, VHF through Dental CAM and Dental CNC give users quite a bit of customization options in terms of the tools they can use and the different strategies and milling speeds that they can implement. So speaking on those strategies and customization options, Dental CAM allows for complete customization over milling options. That gives users the ability to control aspects of both milling speed and performance. So starting with importing STLs into Dental CAM, after you finish your design and you import those into Dental CAM, you'll have the ability to choose between a couple of different options here. You can see in the image on the left, we have a button that allows us to control, there's 3 different stars we can choose from. So 1 star would allow users to really speed up the milling process while sacrificing a little bit of surface quality. There's a middle ground for 2 stars where you could have a better balance between speed and milling quality. And then you also have 3 stars for optimal machining quality, highest, most detail on occlusal surfaces, which will usually prompt you to use smaller tools like a 0.3 millimeter tool to get the most definition out of your units. 1 star would probably be more optimized for a coping or something with a little less anatomical detail. So that's one really quick and easy way for users to decide between speed and quality, depending on what it is they're looking for. In addition to that, within Dental Cam, we have settings that allow us to control different aspects of a restoration and how they're milled for each material type that you use. So in this picture on the right-hand side here, you can see on the left-hand side of that window, we have our different materials that we can choose from. And then within that, we have the ability to customize options for fit, for different tool options that we have available, for different aspects of our restoration, whether it be occlusal surfaces or cavities or screw channels. We have the ability to make decisions about how we want different aspects of those to mill. So when a unit is imported into Dental Cam, it automatically is going to detect certain key anatomical features such as screw channels and cavities, and that's going to allow it to determine optimal machining angles and tool paths. So you can see in these images on the right, we have different areas of our restorations highlighted in green, indicating that the software has detected some kind of anatomical feature, depending on what it is we imported. Sometimes in today's day and age, where users have full flexibility over their design, it can be really challenging to automatically detect some of these things. Because of that, VHF has given users the ability to manually remove and modify those detections. So you can delete them, you can re-add them manually to make sure that those detections are perfect before you calculate that job and send it to the mill. All right, so one of my favorite features within Dental Cam is this residual material display. So after a job has been fully calculated, you have the ability to use this residual material display feature, which gives users the ability to view digital previews of their milling results before they're actually sent to the machine. So this feature actually highlights areas where milling results might deviate from the original STL data. So when we enter this tool, we're able to look at what the original STL data looked like, and we're able to compare that with the actual milling results that we expect to see after the design has been sent to the mill, calculated, and actually manufactured. So we can click on any point on our STL, on our calculated file, and it will actually tell us how much any given area deviates from that point. So you can see a little bit of a chart. You can see as we get into darker blue colors, we're going to see areas that might have a little bit of leftover material that the mill was not able to reach for any given reason. Some of those reasons could be, just a severe undercut. Maybe it's a tight area where the milling burr just wasn't able to quite reach. But I think it gives users a good peace of mind to know what they can expect out of their milling results before they're actually sent to the machine. So they can always go back, they can adjust the angle that things are machined at, they can add different quality settings or speed settings depending on the results that they see here in this residual material display.